afternoon.
Okay.
Today I will start my presentation. And the topic is clustering by Gaussian mixer model and the light gradient boosting machine. This is an unsupervised problem, and I use someone common unsupervised algorithm with supervised algorithm combined together. And my dataset is from Kaggle. Kaggle is a website that offers data science computation platform. And my evaluation matrix is random index and intra-cluster distance and inter-cluster distance. I will introduce this next. Okay, this is my one part of my dataset. My dataset is made up of 29 features, and this dataset have 98,000 data points. In this dataset, each row belongs to a particular cluster, and my job is to predict the cluster each row belongs to. I am not given the training. I'm not given any training data, and I don't know how many clusters my points belong to, and I don't have ground truth label too. Okay. First, when we have a dataset, we need analysis dataset. This two figure is the distribution of two features. My dataset have 29 features. This is two of the 29 features. The feature 10 looks like Gaussian distribution from our experience, and the feature 12 looks like Gaussian distributions. So if we have the assumption, we need to test it. So I use Shapiro-Wilk test and Gaussian dispersion test. These two test methods to figure it out if they are Gaussian distribution or Gaussian distribution. And the result is most of the features are normal distribution, but none feature are Gaussian distribution. So now we have a basic understanding of this data set. For this data set, I have five cluster algorithms to do the cluster. And there are three common unsupervised algorithms, and two unsupervised algorithms combining with supervised algorithms. This is the first one, k-means. K-means is the most common unsupervised algorithm, and it is very easy to carry out. K-means is based on centroid. It's based on centroid base. What does it mean? It means when k-means start work, at first it will set centroids randomly. What is centroid? Centroid is data point at the center of a cluster. So if this is our data, at first it will set centroid randomly, like this. then we need calculate all the distance, all the points, the distance with the centroid. Like this one. This is the distance with centroid 1. This is the distance with this centroid. And we compare the distance, find the shortest one. We find this is shorter than that. So we will assign this point to this cluster. And looks like this figure. We assign all our data points into two clusters. This is the first step. The next step is we have find two clusters. Then we will calculate the mean, the cluster mean. And most of the time, the cluster mean, the true centroid will isn't the same one. The centroid we set randomly. Then we will use the new centroid and do the step 1. Like this. Okay. So this is key means. Sorry. The next unsupervised method is Gaussian mixture model. What Gaussian mixture model means? When we use Gaussian mixture model, we assume all the data is generated by a combination of several Gaussian distributions. Just like this. If we have one-dimension data, we want to apply GMM on this data. We can assume all this data is from 3 Gaussian distributions. The first one, the second one, the third one. And then our job is to find the parameters of all the 3 Gaussian distributions. And also we need to find the complement weight. Like this Gaussian distribution weight is 0.5, and this is 0.3, and this is 0.2. If we have found these parameters, we find out. Then we can get our cluster. For normal Gaussian distribution, let me check my record. Okay, good. Okay, for the simplest Gaussian GMM, we use EM algorithm to complete it. What is EM algorithm? E means exploitation, M means maximization. In E step, we will set the parameters of this Gaussian distribution randomly, just like key means. In key means, we set centroid randomly. In GMM, we set the parameters of Gaussian distribution randomly. step, we need to calculate the expected values of responsibilities. The responsibilities, we can consider it as how the probability one data point belongs to one Gaussian distribution. Yeah, that's like this. This is the formula how to calculate the responsibilities. We need to calculate all the data points, the responsibilities to all the Gaussian distribution. And in end step, our job is use these responsibilities we just calculated and to update the parameters, the Gaussian distribution parameters. So this is EM algorithm. And this is my third unsupervised algorithm, the BGM. This algorithm is more complex than the previous two. In BGM, BGM means Bayesian Gaussian mixture model. It is also a Gaussian mixture model. But in the normal GMM, we use EM algorithm to iteratively get the parameters. And in BGMM, we use variational inference to get our parameters. To find the point estimates of the latent variables. What is latent variables? Latent variables is these three variables. I use fold test. The mixing proportions, high cap, and the mean, the standard deviation. Latent variables means the variable we don't know. We want to find out. And in BGMM, in GMM, when we find the Gaussian distributions parameter, we can get our cluster. In BGMM, when we get the posterior distribution, we can use this to get our cluster. What is posterior distribution? First, we need to know what is prior distribution. And we also need to know what is likelihood. This is hard to understand. I will try my best to make it clear. Okay, first, let's see what is likelihood. Likelihood means the joint probability of observed data viewed as that means we have a data set, and when we set our parameters randomly, we will have a probability. How these parameters likelihood is a concept used in statistics, and it assesses the degree of support that the available evidence provides for a particular hypothesis or model. it represents the probability of observing the given data under a specific set of assumptions or parameter values. If the likelihood is high, it means the parameter we set is more like the true value, and our goal is to maximize the likelihood to find our parameters. Just like this. And the BGMM is based on Bayesian theorem. The Bayesian theorem is easy, just like this. The posterior distribution is the left one, and the prior distribution is this one, PB. This is prior distribution. Prior distribution is we set randomly from our experience. We set randomly, and the PAB is likelihood. We multiply the likelihood and the prior distribution, and then normalize it. We can get our posterior distribution. When we have posterior distribution, we can get the parameters. When we get our parameters, we can cluster our data set. Okay. Bayesian statistics typically involves using probability distributions rather than point probability for the quantities. Bayesian theorem expressed in terms of probability distribution. The Bayesian theorem, this formula is for point probability. I mean, PB is just a value, a specific value. And when we want to apply this theorem on our practical problem, we need to use the probability form, just like this. It is also a Bayesian theorem, and the left one is posterior distribution, and F theta is prior distribution, and this one is likelihood. So when we, in summary, when we use BGM, the first step is we set our prior distribution. The next step is calculate the likelihood. And the third step is multiply them together and normalize it. Then we can get our posterior distribution. When we get our posterior distribution, we can find the parameters. I mean, which value of the parameter is biggest in posterior distribution. Then we choose this parameter. We use this parameter to cluster our data set. Okay. I'm done with the cluster also. Then is a evaluation metric. I use three metrics to evaluate the cluster results. The first metric is rank index. Rank index is the most common evaluation measure for unsupervised learning. This is the source, the rank measure source. This cluster algorithm has the best source is 0.6, not very high. In rank measure, if the source is 1, it means perfect. It means just the same with the ground truth label. If the source is 0, it means have no relationship with the ground truth label. Is the worst. So my source is 0.6, not very high, and also not very low. So what is rank measure? In supervised learning, when we want evaluate the result of supervised learning, we always calculate the accuracy. Like we pick one data point, the predicted label compare with the true label. If they are same, we say, oh yes, it is good. If they are not same, we say the prediction is wrong. But in unsupervised learning, we can do that. In unsupervised learning, we focus on pairs of points, the relationship of pairs of data points. So this is a formula how to calculate the rank measure. A means the relationship of two data points is just the same as truth label. The relationship is just have two options. One is the two data points in same cluster. The other is not in the same cluster. A means these two data points in the same cluster. B means these two data points are not in the same cluster. And we will ending up A and B and derive the all pairs of the number of pairs of data points in our data set. And the second evaluation metric is intra-cluster distance. We can consider it as the diameter of the cluster, the mean diameter of all the cluster. If the intra-cluster distance is low, it means the compactness of our classification result is good. In one word, we want the intra-cluster distance as less as possible, as small as possible. When we calculate the intra-cluster distance, we will find the every mean of cluster and and we need to calculate the average distance between data point to the centroid, the cluster centroid, the average distance. And use this distance and normalize this distance, we will get a mean distance. This distance is the intra-cluster distance. And the formula is like this. And this is my third evaluation metric. It's called intercluster distance. Intercluster distance represents the separation between my cluster. So we want intercluster distance as much as possible. We want it a lot. If the intercluster distance is large, that means the separation between our clusters is good. And how to calculate the intercluster distance? Actually this formula is proposed by me because the common way to calculate the intercluster distance is it is too complex, needs too much calculation. And my method is much simpler, and it's also reasonable. In my method, we will first we also need to get all the centroid of the cluster. If we have 7 clusters, we need to calculate the 7 centroids. Then we pick 1 cluster centroid. Then we will calculate the distance. All the data points, not in cluster 1. The distance between the centroid and the data point. And also we need average. And we will use the number in cluster 1, the number of data points in cluster 1 as weight. And we'll use the weight to normalize it. We will get the mean intercluster distance. And we will compare all the mean intercluster distance from the largest one. The largest one means this algorithm has the best cluster. Yeah. First, we need to calculate the mean distance for every cluster, and then we need to multiply its weight. Use the distance multiply with the weight of one cluster, and then we end it up, and we will have a specific value. For BGMM, the classification result of BGMM, the mean distance is this one. We will compare this value and find the largest one. Okay. Okay. Last, this is my evaluation result. For intercluster distance, GMM has the least, and PGMM with less GBM has the most. So we can say GMM is the worst unsupervised algorithm for our data set. And feihanyang combining with SGBM is the best algorithm for our dataset. And also, based on the evaluation results, it becomes evident that integrating a Gaussian mixed model with a supervised method have better performance compared to employing one single GMM. This is because it can enhance representation. It means compared to just one single unsupervised method, if we combine it with a supervised algorithm, it may have better performance. That's all. Any question?
I just want to ask you the results. So you compare the interdistance between centroid of each cluster. So and you compare between the model.
Sorry.
Yeah, the intercluster distance is so you compare the intercluster distance between each model.
Yeah, each model.
Okay, and you propose that your combination of model, this method is the base based on that result.
Sorry.
And you propose that your results that on your model is the base when compared with other models.
Yeah.
Okay, so you compare only this one or anything else?
Oh, because I have 5 algorithms, so I will have 5 inter-cluster distance. I will compare these 5 values. And also, I will have 5 intra-cluster distance. And I also will compare these 5 values. But for intra-cluster distance, the least one is the best one. For inter-cluster distance, the largest one is the best one.
You also have the result for the comparison of this inter-cluster distance?
Yes, I have, but I don't.
Oh, you should show that.
I don't show that.
Yeah.
And I only show 2 songs. Actually, I have 5 songs. I only show these 2.
So which one is your proposed model? Number 2, BTMM with line GBM, right?
Actually, he means GMM and BGMM, not my proposed model. I only, based on the result of BGM, I combined with supervised algorithm. That GBM is one supervised algorithm. When I use BGMM and I get my cluster, I use this cluster. I divide it into training data and test data, and then I use GBM and then I apply GBM and then I get a result, and this result is a little better than the previous one.
Yeah, just my suggestion, and you can also present like how do you combine this BGM with the light GBM. Maybe you can show the architecture of the algorithm on that, so the audience will get more understanding about this combination of the model.
Yeah.
That's a suggestion.
Thank you.
Because I'm still not clear why this combination of BGMM with the light GBM are, provide a better or advantageous result when compared with another model.
Okay. Thank you. Any question?
I got two questions, and you said you proposed a new equation in intercluster distance. Could you show me the problem? Yeah, this new formula. And did you get any validation with other reference about your new equations? Did you get any
reference?
The reference validation with your new equations. Did you get any validations? Or could you make the same works using the other similar equations to evaluate your systems? Did you make the similar the research works?
No. Why I proposed a new formula? Because the formula I found from the website is usually they can apply on two clusters. Yes, if our data set only have two clusters, we can use the formula from the website to calculate the intercluster distance. But in my cluster, we have 7 clusters, so it will be complex it will be complex if we use the common way to calculate the intercluster distance. So I proposed this. In this formula, yeah, it will much easy for us to get.
Yeah, I think you must to find some other literature reference and to evaluate your works and to prove it's the correction of your data. And okay, yeah. And for the second questions, could you just give me the property of your GMM? GMM and it goes 3 Gauss equations like this, like the motor.
GMM.
Yeah, GMM that goes. Yeah. And I say you. No, and you describe 3 Gauss equation, Gauss equation like model, and this character 1, character 2, character 3, and how do you define the points, in the overlapping area, the repeating points. You can see that points could belong to the character 1 and character 2, and how to define these points.
Responsibilities.
Yeah.
You mean at first we will set the Gaussian distribution randomly.
Yeah.
And we need to calculate every data point to one Gaussian distribution as a responsibility. We will find the like this one. The responsibility to class 1, the responsibility to class 2, the responsibility to class 3. If class 1 is 0.5, to class 2 is 0.4, to class 3 is 0.1. We will find the largest one. The 0.5 is larger than 0.4, larger than 0.1. So we will say, oh yes, this 0 point belongs to cluster 1.
But in the ages of these 2 clusters, cluster 1 and cluster 2, and you must have in your training data set, and you must have some many data and belongs to both belongs to cluster 1 and cluster 2. They always exist in the overlapping area of these 2 clusters. That's how do you define these points, or how do you just to divide these points? because you using 98,000 points to make the training, and the Mars has, and the every point will exist in areas in the physics, and how to clearance to devices in the three different clusters.
You mean how?
I mean, I mean, maybe this one point and have the same, have the
same responsibility.
You have the same distance with cluster one and cluster two, and how do you define this point? You have the same distance between these two clusters. Yeah.
Maybe 15 probability, like
so in the ages.
like Zhu or Con.
Yeah.
I think maybe the responsibility is pretty safe. Yeah, it's pretty safe. Like 0.5, 0.5. But normally it will have a larger one, a bigger one, have a bigger one.